Good morning, children. Today I am going to start some new topics, and these are in continuation with the previous topics taught. And in the last class we were discussing about equilibrium in physical processes. There I taught equilibrium between the solid substance and the liquid substance and the gaseous substance. Right. Now we are going to see the third case where solid substance is in equilibrium with gaseous substance. Right. Remember, this is in continuation with previous class. So solid substance is in equilibrium with gas. This is case 3. There are 3 cases. Three main types you can say in the case of equilibrium in physical changes or physical processes. Now, best example for this is ammonium chloride. It is white colored crystalline solid substance, right? When it undergoes a change, it gives rise to ammonium chloride in gaseous form. When slightly ammonium chloride is heated, right? This is on heating. It becomes gas directly. Next, so formed ammonium chloride gas, if it is condensed or cooled, then it enters into solid form directly. Means, in between solid ammonium chloride and gaseous ammonium chloride, there is no liquid state. Right? So here, heating followed by cooling. And at the same time, this change should be carried out in a closed container. Next, example 2. Iodine crystals, when they are heated, directly it is converted into gas, and when it is cooled, it enters into solid form. Number 3, camphor. When it is heated, directly enters into gaseous form. When the gaseous camphor is cooled, it enters into solid form. Means, in all these 3 examples, heating is followed by cooling. Number 2, all these changes should be carried out in closed container. Otherwise, if the container is opened, the gaseous form of ammonium chloride or iodine or camphor will directly enter into atmosphere. So reversible reaction there will not take place. That is the point. So that's about the equilibrium in physical processes. Okay, now we'll move to the other type, that is equilibrium in chemical processes. Process means it is a change. Right? Now how equilibrium is achieved in the case of chemical reactions. Let us see, there are many examples. I will give 2 examples. If any reaction takes place with the formation of products, by the chemical reaction between the reactants. That is said to be chemical change or chemical reaction. And in that chemical reaction, so formed products, if they react in turn and gives reactants in backward direction, then such a reaction is said to be chemical reaction. Right? Now let us see one example for this type of reaction. That is nitrogen when reacts with hydrogen gas, it gives rise to ammonia gas. Here a particular catalyst, right? Particular temperature, pressure, these are all required. And so formed ammonia gas, if it is not allowed into the atmosphere, and in turn if it undergoes change and in backward direction, if it gives rise to reactants, then after a particular time equilibrium is established between the reactants and the products. Here we have 3 hydrogen atoms. In order to make it even number, we multiply whole NS3 with 2. Now hydrogen atoms have become 6, and here we have only 2 multiplied by 3. Right? And one more thing, equilibrium state can be represented by opposite headed arrow marks in this way also. In previous example it was slightly different, both are representing equilibrium state only. Okay, now we will move to example 2. And in this example we are taking hydrogen gas and we are treating chemically with iodine in gaseous form. Both should be in gaseous form. Actually iodine is solid. Right? When it undergoes sublimation, in the case of solid to gas, physical processes, there we have seen 3 examples where solid is converted into gas directly and gas is converted into solid directly. Right? So such changes are sublimation changes, or sublimation reactions. Now we are taking iodine in solid form and we are subjecting it to sublimation. So we will get gas. And that gas we treat chemically with hydrogen. As a result, we will get hydrogen iodide. Right? If this reaction is carried out in the closed container, then backward reaction will occur. And to balance, we will multiply hydrogen iodide with 2. So in this way, equilibrium is established between reactants and the products. So equilibrium is established when the rate, speed or velocity of forward reaction is equal to the speed, velocity or rate of backward reaction. In chemistry, rate, speed and chemistry means and the velocity means same. So that's about chemical reactions in chemical processes. Equilibrium, how it is achieved in chemical processes. Now we will move to third type of important concept, that is equilibrium constant, and that will be followed by the different factors, how they are going to affect equilibrium state. Right? So equilibrium state and factors affecting equilibrium state. In this we have what do you call law of chemical equilibrium also. Okay, to understand equilibrium state and factors affecting equilibrium, state. We should know the reversible reactions. Now let us see one reversible reaction, that is hydrogen plus iodine. This gives rise to hydrogen iodine. It is a reversible reaction. Right? In this reversible reaction, we have to get equilibrium constant. To get equilibrium constant, we should know what we call law of chemical equilibrium. So according to law of chemical equilibrium, at constant temperature, right? At constant temperature, product of molar concentrations of products involved in the chemical reaction rise it to the stoichiometric constants divided by product of molar concentrations of the reactants involved in the chemical reaction rise it to the individual stoichiometric constants is a constant. Right? So here equilibrium state is obtained, and as far as factors affecting equilibrium state are concerned, there are many factors like temperature, pressure, concentration, catalyst. These are the different factors. So in this case we are going to see the principle, that is Le-Chatelier's principle. This is part of the factors which are going to affect the equilibrium state. To understand those factors in detail, we should know about the Le-Chatelier's principle. So once again, Le-Chatelier's principle can be stated like this: at constant temperature, product of concentrations of the products involved or formed in the chemical reaction rise to the stoichiometric coefficients divided by the product of molar concentrations of the reactants involved in the chemical reaction rise to the stoichiometric constants in equilibrium state. Right? That is equal to constant. Now, if we apply law of chemical equilibrium, so when law of chemical equilibrium is applied, we will get K is equal to molar concentration of hydrogen iodide. Now, stoichiometric constant means we need to take number of moles of this product in the form of power. Here, number of moles of this product is 2. That will become exponent or power divided by molar concentration of hydrogen divided by molar concentration of iodine. This ratio is equal to a constant value. Now this constant K is known as equilibrium constant. Right? So that's about equilibrium constant, how it is obtained. And now let us see the factors which affect equilibrium state of a reversible reaction. Those factors are like this. They are: number 1, concentration. Here concentration refers to those of reactants or the products or both. Here we are discussing about the effect of different factors over equilibrium state. Therefore concentration refers to products besides reactants or vice versa. Next is pressure. Third, temperature. Fourth, catalyst. These are the different factors which affect reversible nature or equilibrium state of the chemical reaction. Now let us see one factor in detail now. First factor is concentration. I'll make it clear the effect of concentration over reversible reaction. Imagine there is a reaction wherein two reactants are reacting together to form the product, that is hydrogen iodide, and those two reactants are hydrogen and iodine, and this is reversible reaction. Now what I am going to do is, we know equilibrium state is established after a particular time. Now the thing is, once the equilibrium state is established, rate of forward reaction becomes exactly equal to that of backward reaction. Right? Now, if I add hydrogen gas, right? When hydrogen gas is added to the above reversible reaction, right? Concentration of reaction mixture will become more. We are not adding iodine, we are adding hydrogen. When some hydrogen gas is added to this reversible reaction, then equilibrium state gets disturbed. As a result, the reaction will occur in forward direction. So when hydrogen gas is added to the above reversible reaction, rate of forward reaction increases. First, reversible state will be disturbed and then again it will be established after a particular time. But once hydrogen gas or iodine, any one of the reactants is added, the reversible state gets disturbed and the reaction will occur in forward direction with more and more speed. That means there are some factors which affect the reversible nature of the reaction. So when such factor is established, the reversible state of the reaction will be changed, and those added factor like concentration refers to quantity of any one of the reactants. Thus added or changed factor will be counteracted in such a way that the reaction is going to get again reversible state after a particular time, and those added substance and its effect will be nullified after a particular time. Now we will move to second factor. Now let us see, children, second factor, that is pressure. We can take same example or a different example. So pressure also affects the equilibrium state. Best example for this is nitrogen gas when chemically reacts with hydrogen gas. Right? It gives rise to ammonia gas. Right? So here reversible reaction is set up. And to balance this, we'll add here 3. And towards left hand side we have 4 moles of reactants, and towards right hand side we have only 2 moles. Now, effect of pressure. How it affects the equilibrium state of this reaction? Let us see. Here altogether we have 4 moles of reactant species. When pressure is applied, reaction mixture gets compressed. When 4 moles of this reaction mixture is compressed to 2 moles, right? When it is compressed means reacting molecules of the reactants are brought very close to each other. That is the meaning, right? Then the number of bombardings means collisions will change. So when pressure is increased, equilibrium will be disturbed. Increased pressure will be nullified again by the same reaction after a particular time when equilibrium is set. So that's how the pressure affects the equilibrium state. Now we will move to third factor, that is temperature. Before going to start temperature, let me tell the nature of the reactions. There are 2 types of reactions which occur either by releasing the energy called exothermic or by absorbing the energy called endothermic. Right? Now we are going to see one example wherein carbon monoxide gas reacts with hydrogen gas, thereby to form methane gas plus water. This is one reaction. So here we have 6 hydrogen atoms, so 3H2. No, 3H2. Right. And this is a reversible reaction. And that too, this is exothermic reaction. So delta H naught value of this reaction, what does delta H, delta H naught stand for? This I taught in thermodynamics chapter. This is equal to minus 206.2 kilojoules per mole. Means that much amount of energy is released in the reaction. So this is exothermic because delta H naught is associated with minus sign. So in this reaction we need not give energy. We need not give. Right? So this reaction is associated with exothermic. So decrease in temperature favors forward reaction. And at the same time, increase in temperature favors backward reaction. Right? This is one example wherein methane and water vapor are formed. Now let us see another example wherein nitrogen gas reacts chemically with hydrogen gas to form ammonia gas. Right? And in this reaction, delta H naught value is negative. That means it is exothermic reaction. Here the amount of energy released is around 93 kilojoules per mole. This much amount of energy is released in this reaction, And this is exothermic reaction. As usual, in the case of exothermic reaction, since energy is released, therefore decrease in heat energy given or decrease in temperature will favor forward reaction, and increase in temperature will favor backward reaction. Means the things that are applicable in the case of example 1 is applicable in the case of example 2, because both example 1 and 2 are exothermic reactions. Now we will move to the other factor, that is concentration over, pressure over, temperature over, and the last factor is catalyst. The role of catalyst in any reaction is to increase the speed of the reaction. Right? Speed of forward reaction, speed of backward reaction. That is the purpose of catalyst. And when you move to class 12, you will learn that catalyst will lower the activation energy of the reactant if it is decomposition reaction, or it lowers the activation energy of the reacting species if it is combination, displacement or double displacement reaction. So here the role of catalyst is to rise the speed of the reaction. Now let us see one best example for this reaction, that is sulfur dioxide is a gas. When it chemically reacts with oxygen gas, right, it gives rise to sulfur trioxide gas. And it is a reversible reaction. This reaction will occur slowly to form the product. If you add small amount of divanadium pentoxide, here catalyst used is divanadium pentoxide. It is V2O5, its composition or formula. Because of that catalyst, what happens is the reacting molecules of oxygen and sulfur dioxide, they will bombard, they collide or hit. The rate of hitting is called collision frequency. Means in a particular time, say per second, how many collisions are going to occur. So that is known as collision frequency. If collision frequency is more, rate of the reaction will also be more. And this is reversible reaction. And here the role of catalyst is to yield more and more sulfur dioxide in a short time. So that's about the role of catalyst, or fourth factor, how it affects the equilibrium state. Okay, now let us see ionic equilibrium. Ionic equilibrium means equilibrium state achieved in the case of ionic equation. That is the meaning. The name or the title itself is informative. Now let us see which are those ionic substances. Fe+3, it is called ferric ion. Fe+2 is ferrous ion. Then this is treated with thiocyanide. Thio means sulfur. AZO means nitrogen. thiocyanide. Then these two will react. As a result, we will get FeSCN plus 2 plus 3 plus minus 1 is equal to plus 2. Iron thiocyanide. And here, once this product is resulted, again it will undergo a change to give back the reactant. Right? So here the thing is, ions are involved on either sides. That means we should know about the formation of ions by the substances. There are some substances which give ions in aqueous medium, and there are some more substances which will give or which will not give ions, but they will give the particles or the molecules when equilibrium is achieved. Right? So that way Faraday classified substances into two types. There are, number one, substances which undergo ionization, thereby to form ions in aqueous medium. They are called electrolytes. And second type, non-electrolytes. And here, electrolytes. As I told you, electrolytes are those substances which give rise to ions in aqueous medium. Again, one more point here. These electrolytes are divided into two types depending on the ease with which the ions are yielded by them. If the ions are formed fast, means if that electrolyte undergoes ionization very fast to form the ions, then it is strong electrolyte. Strong electrolyte. Example, sodium chloride. This sodium chloride in aqueous medium undergoes ionization to form sodium cations in aqueous medium and chloride anions in aqueous medium very fast. Next, second type, weak electrolytes. Weak electrolytes are those substances which undergo ionization very slowly in aqueous medium. Example, ethanoic acid, ammonium hydroxide. Example, if you take ethanoic acid in aqueous medium, it undergoes ionization to form ethanoic ion in aqueous medium and then proton in aqueous medium. So that's about the first type, that is electrolyte, and in that again two categories, strong and weak electrolytes. And non-electrolytes are those electrolytes which do not undergo any ionization in aqueous medium, but that will be divided into molecules. Best example for this is sugar. Right? If we add water to sugar and if we dissolve or glucose, then that will undergo what do you call division, thereby to form the molecules but not ions. That is why aqueous sugar solution doesn't act as what do you call conductor of electricity. It will not conduct. Whereas electrolyte, whether it is strong or weak, it allows electricity to pass through it. That is about ionic equilibrium.